Hello and welcome to this tutorial on our graphing for your upcoming mid-semester exam. Hope everyone is well and able to follow this without too much trouble. So what I'm going to do is open up one of our spreadsheets from the ones I put on Blackboard. So this is just our prac example one. So the idea is that hopefully you've had a go yourself with regards to, in particular, the first graph that we went through, and see if we can come up with some similar values. Now you'll notice that this is different format to perhaps what we collected in class. This is from a metabolic system, the Parvomedics, which is the one we use for research. So this data is real world. We've had to analyze this data and come up with values for as part of a research project. So we can disregard some of the information here, but the information we are interested in is obviously the age of the person, their gender, and obviously their body weight. So obviously those things will be important for some of the analysis that we do. Now, in regards to the columns, there are a number of columns here that aren't necessarily useful for what we're trying to do as well. What we are interested in is obviously the time, which I have converted into minutes for you because, once again, we're doing research quality graphs, so the units have to be SI units. We have VO2, we have our VCO2 in litres per minute, and our ventilation. Our exchange ratio and heart rate, and I guess these two here are the loads on the bike. Now, this is what's programmed into the bike, and this is what was measured. Essentially what it means is we are able to pre-program this as an electronic bike. We don't have to worry about changing the dial like you do with regards to the kilopons on the ones that we use in class. So with this one particular model, we can actually program it through the computer and it automatically just changes the load. And so that was what was programmed and that was what was measured. They're usually pretty similar. It's just that so there's a slight difference. So we will be using this column here for our actual determination of different workloads. So the first one we're going to look at is our ventilatory equivalence. Actually, before we start, what we'll do is we'll just have a brief look at the data at the end here. So one of the very first question you have to do is to work out the VO2 max. Now, we've been through this a number of times, and I know Dave's done a wonderful job of that. He'll probably get a job with Spielberg after this is all over. But the idea being is I'll just quickly run through it again, just the averaging part, just so that we can have a look at some of the types of questions that you'll get in the exam. So here is our values. I want the average of, now I'm going to take the last four legitimate values, if you like, and you'll notice I didn't include this one here. Now, for a number of reasons. One, we can see that it's not the full 15 seconds because these are, give or take, 15-second gas collections. And so it's very much short on that, as well as the actual value in the oxygen consumption has dropped considerably from the preceding values. Furthermore, if I come way over here to the workload, I can see we're up around 250, and then we drop down to 222. So the person's really dialed back. So I'm very, very confident not to include that last row of data. So here's our VO2 max. Now I want to convert that, that's an absolute, so I want to convert that into relative. So you can either do a whole column of this if you wish, or you can just convert it with a calculator. It's up to you. And so we're just going to multiply that by 1,000 because we're going from kilos into mils, and then divide it by their 65 kilos, which was their body weight from up here. And so we come up with this value here. Now, one of the things is please make sure that we're only ever using 2 decimal places for the majority of your values. Obviously, the exception to that is heart rate. So those are my first 2 values for the VO2 max, absolute and relative. So I can now open up a Word document. Please make sure you put your name and student number on here. So for example, I'll put, sorry, it's just people often confuse me for Stone Cold Steve Austin. And so that's my name and student number. So now I can just do, for example, I can go question 1, and I might do ask for a question And it might, this is just might be asking for the max value, so absolute. Once again, make sure you don't forget the units. You will only get half marks if you don't get your full, if you don't put the units there. And we said it was 39.89. Speed typing. Okay, so that's worth 4 marks. Hopefully that should be, everyone should just smash that very easily straight away, because the whole idea is that you know, the max values are what we're after, and then just working out the relative ones should be relatively straightforward. Now, second question, they'll probably be asking about the values themselves and about whether they achieve primary and secondary criteria. And as I said, I know Dave's done a wonderful job of that, and I have been through it in class. So, you know, I probably don't need to go through that again, because I feel that you've probably done enough of that. So essentially what I'm going to do is I'm going to now post the graphs onto here when I've finished them. So I'll leave that document open. And I suggest you do the same when you're doing your exam. You have a Word document open, obviously, and you're able to just go back and forwards. So coming back to our spreadsheet, I am going to do the ventilatory equivalence method first. So I am going to insert a couple of columns, and I will call this column our ventilation VO2 relationship. And so remember, it's a ratio, so it doesn't have units. And like any ratio, it basically looks at the relationship between these values. That's my CO2 ones. And I'm interested in hopefully you guys understanding what happens when these change. Do they change at the same rate? Does one change more than the other? And what does that actually mean, especially from a physiological point of view? So we'll come back to that shortly. So for our function here, we are just simply dividing our ventilation, which is our G29, by our VO2 value in absolute terms. So that's our D29. And we'll do the same. We'll also do the same while we're here in regards to the CO2 ones as well. And that's F29. So, you know, you'll have 2 hours for your exam, and you'll have that extra 15 minutes to tidy things up and to submit it onto Blackboard. And then obviously you won't be able to submit it after that time point. So you do have enough time to do the exam, more than enough time. So you can do this in any way you see. If you've got a faster way of doing your Excel, then by all means use that. So here's our new lot of data here. Now, so the first one, as I said, is our ventilatory equivalence. So I'm just going to highlight this data. And I've included that last line, but it doesn't matter. And then I'll just go to our scatter plot. And there's our graph. Now, obviously, it needs some work. So I'll remind you a couple of times during this video, each graph is worth 6 marks, regardless of whether you identify the threshold or not. It's purely based around the formatting, because I'm a big fan, if you haven't already noticed, of making sure that our graphs are research quality, regardless of what we are preparing them for. You may be in a clinical situation where you have to prepare graphs for the doctor or the medicos or whoever in regards to a patient. You may be dealing with athletes and have to do the same thing. So regardless of where you may or may not end up in life, I think it's really important that you take care in regards to your formatting. So we can get rid of some of these bits and pieces. Once again, this is very much, some graphs may keep them, some may not, but from a point of view in sports science, generally, most research quality journals will have the formatting of the article or your graph not requiring certain things. And for a start, we can get rid of those grid lines and title. Now, what we can see is we're interested in this body of data here, because this is where all the actions taking place, if you like, that we're interested in. And so at the moment, it's quite squishy together. So we can get rid of some of these data points. They're not necessary. The person's just starting out, so their breathing's all over the place, the epinephrine's all over the place. And so we can just come simply back over to here, and we can just highlight those first three numbers will be fine, and we can just delete those, and look what it does to our graph. So it just sort of helps us in regards to the spacing. We can take it a step further if you like, and I often do this as well because we have nothing down here. So we can probably format the axes to start it at 15. So we just right click on that and we can go to format the axes. And we can then make the minimum 15. While we're here, let's add some tick marks. So we go down to here, and then we can just do the major type on the outside only. Once again, I know it's very finicky. And while we're here also, let's change the numbers because we don't need 2 decimal places here. I know I've said before when we're reporting the data, but in a graphical sense here, especially with regards to our ventilatory equivalents, which are unitless, we don't need to have 2 decimal places. So I can go into here and change that to 0. And now if I look at my graph, okay, we can see that it's spaced these out more, and it has changed this to whole numbers with our tick marks at each point. So while I'm here, I'll just move the series up to there. Now I'll do the x-axis the same process again. So I'll basically just go to here. I'm not worried about, I can keep that at 0 to 14, that's fine. I mean, as I said, I could possibly get rid of a little bit there, but that's fine. What I am going to change is obviously the tick marks. I'm going to add those to it. And I'll change the number as well, just to the no decimal places. So there, we have a relatively uniform between the two as far as the numbering is concerned. I mean, it doesn't matter that these are obviously different 5 between because that's determined by the value you're looking at. But essentially what we've got here is making sure that we have uniformity in regards to the numbers and the tick marks and so forth. Let's change the series while we're here. And so I can change that to go up to design, and then I just select my data, and I can then edit our series 1 data and change that to my ventilation VO2. And then I can change the second series to my ventilation CO2. Now there's many different ways you can do that as far as change these, but as I said, if you've got a way of doing it faster, then by all means do that. Once again, I like to change things. So I just like to make that horizontal. I know these things are only small, but it looks better that way, trust me. Now the next thing is let's label our axes while we're here. So now that we're in design, we can just simply go up to here and axes title. So our primary one is our time in minutes. And our secondary one, our vertical axis is our ventilatory equivalence. Now remember, these are unitless, and so therefore we don't need to put anything for that one because it's a ratio. Next step, and once again I've alluded to this in class a number of times, is, sorry, I'll just move that out a bit because I don't like it when it's too squishy there. And I can move that out there, it's a lot better. Is we don't have colors. So once again, some journals do have colors, some don't. Majority ones in sports science, we don't. So let's get into the habit of that. So we can just highlight these and go over to here to our color options, to our markers. And what we'll do is we'll make the, we'll have no fill on them, and we'll make the outside of the darker color. So as you can see, it's changed our VO2 and it's changed it here as well. So we'll do the same for our VCO2. Go to the marker. We will have solid fill for this one in the dark colors, and we will have a solid line also in the dark, which is great. So now we've got a very clear delineation between our VO2 and VCO2. We can quite clearly see the difference there. Now, so this graph's looking great. It's you know, we may or may not be ready to take it across the other side. Let me have a look. I need to get rid of the boxes around the outside of the graph, so I can just go to format the chart area, and I just want no line. So now you'll see that the line around the outside is gone. Technically, I could get rid of the white background, but we don't need to because it's getting pasted onto a white paper, obviously. So let's have a look at this graph and have a bit of a bo peep at working out where our thresholds occur. So now I'm sort of looking at this, and I'm thinking I might be giving myself 6 out of 6 for this. I'll probably change that to 11. I know it's once again being a little bit picky, but remember, my eyesight's going, or no, it just looks better this way. So if it's too small, the last thing you want to do is make it difficult for the person to read those. I'm okay with these ones. These are always slightly smaller. So back to our graph, looking at how we determine the threshold. So it's where we're getting a rise with our VO2 without a rise in VCO2. In previous years, I've asked, okay, that's the definition. Why do we choose that? Tell me about the physiology behind what's occurring at that point. Why do we choose it so when one's rising, one's not? Why is one rising and one's not? So like anything, it's really good that you're able to do the graphs and work out the data point, but I'd really like you to understand the physiology behind the data point as well. So coming back to our graph, it's a little bit of a tricky one. So this exam, or this spreadsheet, is actually one I used previous years, and it was quite difficult for the students. So I've changed the one for this year. Yours has still got a couple of twists in it just to make it interesting. But so we've got a bit of a problem with a couple of values here that are sort of what I consider to be outliers. And sometimes you can choose not to include them in your analysis. And I know that may sound a little bit dodgy, or how do you know when to include them or not, but I'll go through that explanation with you. So one of the better ways I've found is just going to the insert, and we will bring out a straight line. And so what I'm looking for, so here's my VO2 data. So what I'm looking for is that rise. So I'm going to draw a straight line through here. And so what I'm looking for is a rise in my VO2 data without a rise in my VCO2 data. Now, I'm thinking there's something happening around this data point here. Now, you could argue that you've got one down here and you've got one over here, but I would consider those two to be what I referred to as outliers. Now, something's happened at those points. Person's held their breath, they've breathed out extra hard. That's disturbed I guess, the normal flow of the data. So remembering what we're looking for here is a change in the general trend. So the general trend is we've got it scooting along here, and then it's all of a sudden it's starting to rise. So these two guys are sort of outside that normal, if you like, rhythm of the person's oxygen consumption and ventilation. We're certainly getting no change or no increase in our VCO2. So I am leaning towards around this data point here is our around 0.5, so 503. So I'll go back over here and I can highlight 503. So I'm looking at around this data point as a possible first point of leaving this line of linearity, or the normal flow of that data. As I said, we've still got two here, but I'd be inclined to almost not count those ones. You know, so the idea being is because they're not part of the normal flow. You know, we've got another point up here, 547, but I'm more than happy to say, well, this line of best fit through here represents the majority of that early data, and we've sort of got leaving that point at around the 5. But we'll come back to that, because the whole idea is it's very subjective, and I understand that. But what we're going to do is we can eyeball the data, and we can also do the second graph to help us understand what's occurring there. So if I have a look at what's occurring at this 503, and my main indicator is this guy here. And so if I have a look at the CO2, I can see, once again, disregarding the early data, was 5, 6, 6s up to 7. So it's creeping up a little bit, yeah, because we are increasing our oxygen consumption, therefore using more oxidative pathways. And if remembering, where does the CO2 come from during oxidative pathways? The TCA cycle. So therefore, sure, we're getting extra CO2 being produced, but it's just from the actual increase in oxygen consumption passing through there. Increasing again up to 7, 8, 8, 1, so it's ones, and then all of a sudden it charges up to 122, a little bit back down again, and then takes off. So we've got something happening around this data point. And so I am, building up a case, if you like, to suggest that, okay, I'm around the 518 mark is going to be where I'm sort of suggesting that that threshold may be. So I am reasonably confident in that regard. I need more evidence. So what I'm going to do is obviously have a look at the other graph. So in the meantime, what I can do is I can highlight this one. I might highlight that line as well. So then when I copy, I can then go to my Word document, and when I paste, the line's way up there, so as you see, and the graph looks totally different. So sometimes you may want to not do the line because we need to change this a little bit. I need to make it a bit larger. So okay, so I'm sort of happy with that now. So what I can do here is, excuse me, add in now just the description of this, if you like. So the description is obviously the figure that we're going to give it. So I'll just say this is, for argument's sake, it's figure 1, for example, and then I can give them a brief description. Now, depending on obviously the journal that you are with, will change dramatically about the description you give it here. Once again, a majority of sport and exercise science journals just want a brief description. So we're looking at something along the lines of, say, for example, the detection, and this is just, that you can make up yourself as far as whatever words you're going to put in there. But as I said, it's just a very brief description. Better get the spelling right, I guess. Now this is where I'll try and use the correct terminology. So try and use the gas exchange threshold as opposed to anaerobic threshold. I guess if you put anaerobic threshold, you're not incorrect, but let's try and use the right terminology. So the detection of gas exchange threshold using the ventilatory equivalence method. And so I'm more than happy with that as being the description that we're going to utilize for the graph. And so that's very brief, and that's all it needs to be. Now, if you wanted to, as I said, the formatting, so once again, I'd come back to here, and if I just want to be extra especially fussy, sorry, let me just change that. So I'm pretty happy with that. I might just move that out of touch. It's a bit squishy. Okay, so I'm pretty happy with that. Now, if you want to, that's to me is the finished product, and I'd probably, after trying desperately to find something wrong with it, I can't, so therefore I'd have to give it 6 out of 6. You can if you want to, you're not marked on this because you can add, as I said, that line if you want to, just to help you with your understanding about what you're looking for here. And obviously it helps, I guess in some regard, the understanding about what you're trying to achieve, I guess, as far as detect that point. So I'll just change that color. And so that may help you in your understanding of what we're after there. Just putting that line in there just to help you with regards to, okay, we've sort of selected around, the 5 point as being where we think that that threshold may be, according to what we get early on in the data here. We can see up the other end, there's quite a lot happening as well. So have a think about what happens here, for example, when we start to get a mismatch in our CO2 production, okay, and our ventilation. Because remembering up until I guess the majority of our exercise here, the ventilation is driven by CO2 production. So therefore, as CO2 goes up, ventilation goes up. So in other words, the ratio doesn't tend to change too much. In fact, we can see it coming down a little bit, but what happens here is it starts to go up again. So obviously something else is stimulating the ventilation, and that's where we talk about perhaps it's the change in pH due to the hydrogen ion concentration. So therefore, possibly up here we have sort of the RCT, the respiratory compensation threshold, where we start to get that hyper increase in the amount of CO2 ventilation. So one could also argue we around this point might be around the obla, the 4 millimoles, the critical power level I've spoken about, but we don't have any way of confirming that. So at the moment, we're just identifying the anaerobic or the gas exchange threshold. So let's move on then. We're happy with that one. Hopefully we're getting our 6 out of 6 there, and we're going to go back to our spreadsheet. And just bearing in mind, we've sort of, thought about around this particular data point, is where we're sort of assuming that we may have achieved our threshold. So what we're going to do now is the other graph. So I can just leave that one there. So I'm now just interested in my VO2 data. Include that last data point, it doesn't matter. And my CO2 data. So I'm just going to highlight those two columns. And once again, same procedure, just go through and do your graph. And so then we end up with something like this, which is pretty similar to what we had before. So I just have to race through and I'll just pop it there so I can have a look up here. Okay, so now I can just quickly run through and just do those changes again. I see the idea is if you practice this graphing, just the formatting alone, so when you do the exam, it shouldn't take you long at all, so you can devote more time to the actual, I guess, the answering of the other questions as opposed to time trying to do the formatting. So we'll change our markers. So what we want there is just, once again, we'll change it to the dark color. Okay, obviously we just have one data set here. Now our units, I like these to be uniform. So the idea, I know this is 3.5, so what I'm going to do is change this one here. So when I format my axes, obviously I do my tick marks as per usual. But what I'll also do is take this up to 3.5. So I just have uniformity between the two. So over here, just the tick marks I'll be just adding to that one. So what I need to do here is just add our titles. So once again, I can just go to axes titles, the primary one. So that's my VO2. Don't forget your units. Whoops, and make sure you put the number in there. You don't have to superscript it, that's fine. And we'll have a look at the vertical axes. And so here where we have just our CO2 data. Okay. So I'll just tidy these up a little bit. So I'm reasonably happy with that as far as the formatting is concerned. I have got the right units. Obviously, I don't need a figure legend in here. So what I could possibly do, which I should have done, is perhaps put a bracket around these. So as I said, always double check what it's looking like, just in case that you've made a mistake. And I mean, if you do get time, you could possibly print this off and before you actually send it. Now that will just help you make sure that you've actually done it correctly as far as how it looks. But if you don't get time, then don't worry too much about trying to print it off. Essentially, you need to just save it and then submit it onto Blackboard as per normal. Okay, so here's our graph So what we're looking for here is, once again, we're going to use the lines to help us. And what I'm going to do is now refer to the article about this. So I will bring in this article here. So this is one that's on Blackboard. And I've referred to this already a couple of times in class. It's written by my old exercise physiology lecturer, Donald. And so he sort of came up with this simplified method, because normally you have to use a computer to use this V-slope, computerized V-slope method. So what we can do is we don't need that. So we're going to use the simplified V-slope. And so we have our VCO2 and VO2 on equal axes. And here it talks about, okay, we can disregard the early data, because once again, it sort of can add to changes in our linearity that we're looking at. And what he's after is he uses a triangle to have this line of linearity. Well, with the drawing tool, we don't need to do that. And it says here, usually did not pass through the zero origin. So in other words, the meeting of the X and Y axes. And what we're looking for, so most importantly, the first point of consistent departure from linearity was visually selected by 2 independent investigators. So as I said, it's very subjective. And obviously experience helps, but also the idea of having 2 people see if they get the same answer. Obviously, you only got yourself, hopefully. There's no one else there helping you. And so therefore, you just have to go with the 2 graphs to see if they can basically act like the 2 independent people to help you make your decision about where you select it. I'm also using this guidance here. If you are within 30 seconds of what I choose, then you'll be marked correct. So for example, if we go back to our data, and I'm sort of thinking it's occurring perhaps around this 5 mark here. So you do have a bit of a window around that to select the same data point as myself. So I'm more than happy with that. So therefore it allows you some sort of leeway. You know, if you're way up here, then we're outside that 30 seconds. If you're here, we're outside the 30 seconds. So, you know, as long as you're reasonably close to what I've selected, then I'm more than happy with that. So coming back to our graph, so I'm going to grab the drawing tool again and just drop on that straight line. So what I'm after is, said we could disregard this data here, but interestingly enough, it sort of does actually form part of the line. So if I'm doing a line of best fit, I'm sort of looking at my line about there. I'm not purposely going through here. I'm mainly looking at this data here. And so if I had to do a line of best fit through that early data, that's where I'd select it. And lo and behold, it happens to actually go through the 0, point. So it's sort of, you know, could you say that helps you make your decision? Well, you could possibly, but just remember it's not part of the definition. But if we are, you know, nevertheless, what we're mainly after is this going through the majority of data here. So once again, if we remember the article, we're sort of looking at a data point that leaves that line of linearity. So about for, according to here, around about 1.37 in our oxygen consumption. So if I come back over here and look at 1.37 in my VO2 column, lo and behold, I am at 5 minutes. So I'm now reasonably confident I've nailed the correct position of the gas exchange threshold. Very confident. You know, both graphs are sort of telling me a reasonably similar story as far as where that selection could possibly be. So that straight line, as I said, remember the definition. If you're not sure, you can have the article next to you whilst you are obviously doing this exam, and it helps you understand that it's the departure from the linearity by the first point of consistent departure. So I like how they use the word consistent, because up here we had, you know, these outliers that sort of gave us a lack of consistency. So here, the V-slope method, and there are a number of research articles that sort of suggest that this may in fact be a more accurate measure than that. And I'll explain why in a second. But nevertheless, I am pretty confident we have nailed this from the point of view of selecting. I would be inclined to go with 503. Now, as I said, if you've got a 30-second window around there, so if you've selected anything around that point, then I would consider to you to be reasonably accurate. So to get the correct marks. So we can do the same business here. We can then just copy our graph and go back to our Word document, and we can paste that in there. So notice how it's chucked it onto the next page, and that's fine. Make sure that if it does go across 2 pages, you don't have half of it on one page and half on another. Sort of don't start the graph here and then have like this part here on the next page. So the idea being is you want all of it to be on the same page. And I don't care if you have it as an appendix, as I said, you can do that, or you can have it on 2 separate pages. If it won't fit on one page, that's fine. So I'm just cut and pasted that definition, and I'll just change a few bits and pieces there. So this is using the V-slope method. Now, some people in the past, which is again, you can do this if you want, they've got the line there, or you may in fact, if you want to be fancy pants, you can put an arrow on here, and what you can do is put the arrow tool on there and have it the same color, and you could here put indicates the get. Okay, so that just lets me know that you've picked the right point. But as I said, I'm just it's mainly about the formatting here. Once again, I'll just change that up to 11. So because they have to match the other graph. I do like it so the two graphs are the same in that regard. And I'll just move that up a fraction. Okay, so I'm looking at this now and going, yeah, I'm pretty happy with that. You know, I would be so kind as to give myself probably 6 out of 6 as well, unless I can find something in there that I don't like. I've got the units. I don't necessarily have to make that subscript. I don't have to put the -1 up there. We're not going to go that far. But this is about the right size. It's got the satisfactory description here. So I'm very happy with that particular graph. So that's the graphing. That's, you know, as I said, what I'd consider to be reasonably easy marks. Here you could put something like, you know, line indicates anaerobic threshold. Oh, sorry. The get. So, you know, just if you've put something on here, you need to just put it down here as to what that actually indicates. Remember, a person needs to be able to look at this graph and understand what you're trying to do with it, as far as, you don't have to have a detailed description about, you know, when the VO2 leaves the line of linearity is where we detect it. That's too much detail. All we have to have is a brief description here. So those are the 2 graphs, and I'm very happy with how they look. So let's now take it a step further, and I don't mind showing you these next questions because obviously the answers are going to be different because your data is different. But what we get from this is the numbers. So what I'm going to do now is I'll put in, let's say, I can't remember what it is, but I think it's about one of the questions later on. But essentially, this is where you get your marks as far as working out the correct thresholds. So I might have something like a table that that you've got in here. So it might be something along the lines of that, for example, and it might have here. It might have, actually, I need to have one more. So I might have, for example, here it might be VO2. It might be heart rate, and it might be the power. And so what I'm after, so just once again, you know, just make sure that we always have the units after the term, for example. So okay, so here it might be, for example, I want so the gas exchange threshold. Absolute value. And so what I'm after here is the absolute value that the gas exchange occurs on. So if I flick back to my graph here, and I've selected 5 minutes, for example, so 1.37. So I can then go back to my Word document and put in 1.37. I don't have to worry about units because I've got it up there. I then want to have a look at the heart rate and the power, the same deal. So I want to go back and have a look at those. Just move those out of the way. And so at 5 minutes, I have a heart rate of 159. I do not have half a heartbeat. Please don't put down decimals for that. So that's 159. And then the same for the power. So this is where, you know, obviously your marks are very important. Actually, I think, yeah, so this is where obviously the marks come for you detecting the right point. As I said, not so much from the graph, but actually from this particular methodology here. So the power, so just back to our spreadsheet again, and 108 watts, because I mean, I'm going to round that up to 108. If you put down 107, you'd be fine. You can see 108 was programmed, 100, so I'm just going to say about 108 watts for that particular one. Okay, so now what I want is I'll write it down a full. So a percentage of maximum. And then what we can actually, what I have down here is probably maximum values. So what was the person's VO2 max? You know, 2.59, if I remember correctly. What was the maximum heart rate? I mean, honestly, these are worth marks, and all you have to do is go and look at the spreadsheet. So it should be easily full marks. A little bit, I said this one's a bit trickier because as you guys would be well aware, here's our heart rate. And it's like, well, what's happened down here? And oh, our wonderful technology, the polar's dropped out. Surprise, surprise. So our peak heart rate occurs way back here. So it's 194. Okay, so not the 0.86, so 194 beats per minute is our maximum heart rate. So I can just go back to here and put that in. And then I can put in the peak power. So in other words, the maximum power that was generated. Once again, I'm not going to take that value like I mentioned before. I'm going to take the maximum value of, I'm just going to make that 252. Once again, if you put down 251.72, you're fine, but I'm going to put down 252. That's okay. When it comes to power output, point something is not going to make a difference. So now the percentage of the maximum. And I can just, well, you guys can have a calculator next to you. Obviously, when we're normally in the computer labs, you can just go jump to the calculator function. But so the idea being is now is I need to, what percentage did that VO2 occur? So it's simply 1.37 divided by my 2.59. And so that's at 52.9. So I'll just go, percentage will just be 1 decimal point. Same with the heart rate. So I can do the same deal here. So 159 divided by my 194. And so that's 82. So big difference there. Let's have a look at the power. 108 divided by our 252. 42.85. So 42.8.9 will do. I'll just double check that. 108 was 108. Yep, so that's fine. So coming back to our Word document, we can see quite a big difference here in regards to these values. And so therefore it is important that, and this is where, you know, if you looked at the Paula Radcliffe video I put up and understanding about different training zones and stuff, so we can see for this particular case, the person's only operating at 50%, but they're still, you know, punching out 80% of their heart rate. So there's a big difference there. And then obviously they've got a little bit of more wriggle room here in regards to their power output. Another way in which we can sort of, I guess, reinforce our finding of this particular point is to go, well, okay, how does this VO2 compare to a person of a similar age and gender? So just going back to here, so we got to 39.89. So how does that compare to our 21-year-old female? And so remembering the table where it had all those terrible definitions of good, bad, or high or really high. So I much prefer if you had, sedentary, healthy, untrained, trained and highly trained, and maybe even elite as a very end stage. But 39.89 for our 21-year-old female would probably be around about physically active, healthy, but not trained. It's probably right on the cusp. I think around about 35 is what would normally sort of get. So I am confident that, okay, that would be my description, and that may very well be one of your questions about where does this person lie. So remember, don't just say they're fit or they're unfit or they're sedentary or they're highly trained. Talk to me about the other values for someone of a similar age and gender. So coming back to here, our person is healthy but untrained, physically active but untrained. So when I then go and look at my value here, what is normally the percentage that the gas exchange or the anaerobic threshold occurs at for an untrained but healthy person? It's normally around 50-60%. So once again, adding to my I guess the calculation of where I think the anaerobic threshold or the gas exchange threshold is, then I am very confident again that my data is sort of supporting it from the point of view of, yes, this person is around about the right sort of VO2, and an untrained person tends to have a threshold between the 50 and 60%. Now, if the person's VO2 was a lot higher, then you'd obviously expect the gas exchange threshold to be higher. It's not always the case, but generally you would find that. So once again, this sort of lends support to my mind that I've selected the right point. Other things you'll have to do for the exam, selecting the critical power, and I think we've been through that in class. So if you're not sure, just refer to the lecture slides. And there'll be a few other bits and pieces, but they're all based around this particular spreadsheet, based around your understanding about a VO2 max test. It might be protocols, for example. It might be safety procedures during the protocols. So there could be any number of issues there. Comparison between bike and treadmill, because we did those in class. So make sure you've got all those on hand, that information. As I said, it's now that you're doing this at home, so it is open book, obviously. You've got your lecture slides next to you. You've got the articles next to you, which you've all read 10 times. Instead of having PubMed Fridays now, you could have PubMed every day. I mean, that's just too much joy to even talk about. So there should be no excuses for actually doing better than normal, perhaps, in regards to your results. So by the time you listen to this, you should have, I will decide on what day and time that the exam will take place. At this stage, I am looking at week 8. So that is after the mid-semester break. Now that it'll occur during that week. So most likely I will make it on the Friday at our normal lecture time, which was between 10 and 12. So that way, I'm hopefully giving, that's the, let me just double check, that's the 24th of April. So that's it's quite a ways away from where we are now. So that gives you a good amount of time to practice, to go through those and to ensure that you have your graphing down well. So I don't want to, as I said, have the exam sort of next week, because obviously we've got Easter and it doesn't give you enough time to practice, and then we have the break. So that's why it's sort of been put back to week 8, just to allow you that time to practice. So have a crack at doing this spreadsheet if you haven't already, and see if you can come up with similar answers. I will be in my office for phone calls and stuff if you need to talk to me about anything in particular that's urgent. 54594464 is the number. And so I will be continuing as per normal. I know a lot of lecturers are doing stuff from home, but I will definitely be coming into my office to do the work and to do the subsequent PowerPoint presentations as well. So I think that's about it for this particular tutorial. I think Dave might also be doing some Zoom sessions as well, if you want to have a bit of a chat with him in regards to some of the stuff. Yeah, I know he's posted that spreadsheet analysis about how to do the numbering as far as the averaging, and then looking at the working out, did the person achieve primary and secondary criteria and so forth. So have a think about making sure that you've got that time available on the 24th of April between 10 and 12, and I will put on Blackboard. It'll be the very first thing on Blackboard, your exam. It will be available bang on 10 o'clock on that day, and it will run for 2 hours 15. So you'll have 2 hours 15 in order to complete the exam and to submit it to me, and then it'll obviously, submission won't be possible after that time. So if for some reason you can't, you're going to have to let me know, can't make that time, but most people are self-isolating. But then I realize there are some people at home that might be having to look after the tribe. And so therefore, just let me know, and we'll work out something else. But I think the majority of people should be able to fit in that time slot, unless you have something else on. So good luck with this. It's probably not ideal, but we have to be flexible in this day and age. And essentially, that was the tutorial I was going to give in person anyway. So please feel free just to contact me if there's something that hasn't come out properly, or you're still not sure about something. I'm more than happy to answer emails and stuff like that. So I don't necessarily want to look at 1,000 graphs. So make sure you have a good crack at those and see if you can work out the thresholds. Good luck with the exam, and hopefully everyone keeps healthy and well. Thanks.